We're going to look at a few examples. A couple of the ones at the end we're not going to do today just because I've done them as an experiment before and it just ends up being kind of a mess. So we're going to talk about them, but we're not actually going to do the experiment. So it starts with a quote, unlikely events occur every day, but we can't predict which unlikely event will occur today. Right? Lots of unlikely things happen. Right? But do you know which unlikely thing is going to happen? No.
Like Liam chuckling. He's like, that was unlikely.
Okay. Suppose that 40% of the cars in our area are manufactured in the United States, 30% from Japan, 10% in Germany, and 20% in other countries. If cars are selected from this group at random, find the probability that, first, a car is not U.S. made. Well, the probability that it's U.S. made, and this is how you show that. What percent are made in the U.S.? 40%. So this is going to be the complement of that. That'd be 1 minus 0.4 is 0.6. We typically give these as decimals and not as percentages. It's not wrong if you do the percentage. It's just typically that's how we do it.
Is there a particular reason?
I think it's just kind of the way it is. It's less writing. You know how mathematicians are. Although these are statisticians, so they shouldn't be as lazy, but I don't know.
Is it like a hierarchy of laziness?
All right. So the probability that a car is made in either Japan or Germany. How do we calculate that? Well, that's the probability that it's made in Japan plus the probability that it's made in Germany. What do we call those two possibilities? Since if one of them happens, the other one cannot happen.
Mutually exclusive.
Mutually exclusive, or the other word for that is, someone said it, disjoint. So we'll just add these two probabilities together. So Japan is 0.3, Germany is 0.1, so this is 0.4. So what's the probability that you see a car from Japan and then the next one is also from Japan? So the probability that it's Japan and then Japan again. How do we do that? Multiply the probability that it's made in Japan. So that'd be 0.3 times 0.3 is 0.09. So there's less than a 10% chance that you'll see two in a row. All right. So what's the probability that you see 3 cars in a row, none of which are from Germany? So this is the probability of not Germany and not Germany and not Germany. What's the probability that the first one is not from Germany? 90%. Yeah, 1 minus 0.1. So if you wanted to write it that way, this would be 1 minus 0.1 times 1 minus 0.1 times 1 minus 0.1. If you want to cut straight to the chase and just say it's 0.9 times 0.9 times 0.9, that is absolutely fine. I don't know what that is. Yep, 0.729.
No, you did. You also don't understand.
So that's relatively good odds that you'll see 3 in a row that aren't from Germany. But German cars are fairly rare in this particular setup. All right, how about this one? that at least one of 3 cars selected is US made. There are 2 different ways to do this, and one of them is really hard and one of them is way a lot easier. We've already talked about it once when we were going over homework. Does anyone remember how we can find this probability? All I'm hearing is it's like watching Charlie Brown cartoons.
Claire first.
Okay.
Christina second. Ready, Claire?
Now, Claire, go ahead.
No, Claire. We would like to hear from you.
Is it the zero? Is you're less than or greater to 1 or something like that?
0 is less than 1, yes.
Well, yeah, I don't know, but it's something like that.
It has something to do with, yeah.
From there?
Christina, restart from there.
Yeah.
Like, all the others are from Alright.
Man, I can't get a complete sentence out of anybody.
Christina, you got this.
Do y'all have anything else, guys?
Usually this is me. Yes, Jackson.
All right. So the probability that at least one, and that's the big part, at least one that it's US made, is equal to 1 minus the probability that none are from the US. Because that covers all the other possibilities, right? Now, on this one, it's not too awfully bad. You could probably do it the other way, but when you have 49 different things, it's way easier to do it this way. So this is going to be equal to 1 minus, what's the probability that none of them, or how are we going to find the probability that none of them are made in the US?
What's the probability of them being in the US?
What's the probability that the first one is not in the US? What's the probability that the next one is not in the US? What's the probability that the third one is not in the United States? So, and those are independent events, so what are we going to do with those? Multiply them. Now, after a while, you get tired of writing out 0.6 so many times, so we'll just say 0.6 to the third.
Genius alert. Well, I can't call Mr. Davis a genius.
And that's 0.784.
Boy, Mr. Davis. Stop.
All right, this last one's one of my favorite ones. The first Japanese car you choose is the 4th car that you choose.
Absolutely not. Oh, wait, it just means that the fourth car that you've chosen is a Japanese car.
It has to be Japanese. So what do the first 3 have to be?
Not Japanese.
Not Japanese. All right. So what's the probability that it's not Japanese?
Bro. No, 0.7. No.
So this would be 0.7. And how many not Japanese do we want to have? 3 in a row. And then the next one, we want to have a Japanese car. 0.3. So that's 0.7 raised to the third times 0.3. It's 0.1029. So about a 10% chance. By the way, this is the same probability as the first car you see is Japanese and the next 3 aren't. Or that the first one's not, the second one is, and the next 2 aren't. All those probabilities are the same. Okay?
It's like picking 4 out of a hat and one of them is Japanese. Or no?
No, he's on something here. No.
No, because if you're putting it back.
Well, yeah. The problem is that we are putting them back. It's not.
Oh, okay.
Yeah, this is with replacement. We're assuming that there's such a large number of cars in the area that picking the first one doesn't affect any of these percentages.
We're probably.
Jumping on the bed.
I mean,
Oh, this is talking about the entire United
95%
States.
chance of one
well,
falling
no,
off
it's in your area.
Oh, if it's in your area,
Next
that's fine.
bedroom.
It depends on what you define as your area. The greater Houston area,
Greater Houston area probably doesn't matter. but, like,
it probably
the greater
doesn't.
Northland area probably matters.
Right. If it's in my parking lot, it probably does affect it quite a lot. All right.
Will fall off the bed.
So
Can I read this one?
The worst is area.
you have to read it, in rhythm.
Okay. 10 little monkeys were jumping on a bed. There's a 35 chance someone will fall and bump its head. In the bedroom next door, 5 kangaroos were jumping on a bed. Man, there's no rhythm here. Being more adept at jumping first only have 20% chance that a kangaroo will fall off the bed.
Keep going.
No, that's it.
At,
That's it.
at first, it's like, oh, I can do this, and then you get, especially when you get to the adept part, it's like the rhythm comes to a screeching halt. All right. So, what's the probability that in a single night, it doesn't say that, but it's implied, that both a monkey and a kangaroo will fall off the bed? Yeah. 0.35 times 0.2, which is 0.07.
007.
Pardon?
Should you have your head?
007.
No, it's not 007. It's got a decimal
Oh, that's
point in
right.
it.
This
On
Davis?
your head.
This is
35
Davis.
times
Yeah,
2,
two.
you just move the decimal.
Yeah, that one's not real
No, it's not
difficult.
real difficult.
He's gonna lower your test right now.
Just lost 2
All right.
points.
What are the chances that a monkey will not fall off the bed?
165.
Because it's 1 minus 0.35. That's the complement. So, if the monkeys do this every night for a week,
They're going to the hospital.
there is no concussion protocol for the monkeys. What are the chances that a monkey falls off the bed every single one of the 7 nights? 0.35 times 7? That's going to be more than 1. To the 7th power.
Because you multiply by it, so.
It's the percentages.
Hey.
That's almost impossible. It's 0.0006439.
Give a monkey a typewriter.
Given an infinite number of monkeys, an infinite number of typewriters, and eventually one of them will turn out the complete works of Shakespeare. I actually don't subscribe to that.
Oh, how? Interesting.
I think that you would get, because you're not getting unique manuscripts. So I think that you would get multiple ones that were exactly the same pile of illegible garbage.
What if there's infinite time?
There is, yeah, a
You just
world.
have to have faith in the monkeys.
Infinite time, infinite
I think
typewriters, infinite
equals
monkeys.
infinite
Infinite
amount of
possibilities.
worlds.
Yeah,
Yeah,
no,
most of
no,
those.
no one said infinite time, but
Oh.
I guess my thought of it is infinite time. Because like,
Well, what if the
you
monkey?
have
Yeah,
to give
that's
them
what I
enough
was thinking
time
about
to,
it.
yeah,
to type all the, the words.
There is a world.
yeah.
And also like
the monkey.
every third word is
All right.
every
It's a
thing.
word.
What are the chances that if the monkeys jump every day for a week, that at least one will fall off the bed?
Is it this? It's the. No.
It's
no,
the-
not the same. It's not the same.
It's the
That was a stupid thing. Complement of that?
Complement of what?
Of part C.
C.
Oh, no.
He's gonna say that. We're not really.
No, because I mean, C is 1 falls off every day.
C is 1 falls off.
So it's going to be 1 minus the probability that none of them fall off.
Oh, yeah. This
Oh,
is like the.
yeah, that makes sense.
Okay.
So it'd be 1 minus 0.65 to the 7th.
Yeah, that
like
At least one will fall off the bed.
Shepherd gets the answer.
6, 7. Yeah, I'm not gonna lie, guys. This one kind of confuses me.
Shepherd boy.
Anyone
What's
else?
that?
Anyone else?
No, because it's the
No.
same as the above example.
No,
No.
but in my mind, it's not. That's the issue.
It's the same as this one.
Yeah, I know.
At least one is equal to 1 minus the probability that none.
Yes, Shepherd. What do you not
It's
understand?
just been a long day. All the words are sounding the same.
It's okay.
I'll figure it out.
All right. What is the probability that the Kangaroos will not have anyone fall off the bed 4 nights in a row, only to have their streak ended by one falling off, by one taking a fall on the 5th night?
Is it 0.8 to the
0.8
4th
to the 4th times
times 0.2?
So, yeah, 4 in a row
Yeah, I think
of not, and then they lose their streak.
It's unfortunate. Imagine being that kangaroo that falls off on the 5th night.
How would you feel, Liam, if you were that kangaroo?
I feel like
Am I gonna fail this sound test?
0.08192. So a little less than a 10% chance.
And they still fell off.
The odds were in their favor,
The odds were in their favor.
but there was.
All right, let's go on to the back.
Me too.
So I want to spend some time talking about number 3. The monkeys in problem number 2 managed to go a whole week without someone bumping their head. One of the kangaroos insists that they are due for a fall.
There's no law.
Another one says that the monkeys must be getting better at their jumping skills. What do you think and why? So,
Neither are correct. There's no law of averages.
Because
So
every single time
they're
it's
not
wrong.
due for a certain fall.
They're
It's
not.
just like the odds have been
They're
the
not-
same chance
They're
over
all
and over. They've gotten lucky.
They're not
okay,
getting
so
better,
it's
they're all-
improbable, but
It's improbable, but not impossible. It doesn't indicate that they're getting better either.
okay, why do you say that it doesn't indicate that they're getting better?
Because
Because
there's
it's
no
always 35%.
there's no proof. And also like it's 7 days. That's just
Because
7
each
times.
night is an independent
Always.
event.
Yeah.
So if we assume that each night is independent, but so the reason that it doesn't prove conclusively that they're getting better is, well, could they have 7 good nights in a row?
Yeah.
Yes.
Yes.
You know,
Yes.
They are not.
there are all sorts of examples from sports where someone who is really not a good player has a terrific, half of football or something, and people start saying that they're amazing. Trevor Lawrence. Whew.
Yeah.
Seriously, he made bank on, he had one good half of football in a playoff game, and he has made millions of dollars off of that. He's not all that good as an NFL quarterback. I always put that in.
Yeah.
It's not that he's not good. He's really good. But as an NFL level quarterback, schmeh.
But our middle
Yeah,
school
I like that. I'm gonna start calling people schmeh.
Schmeh.
Off in their contract years.
You think you could hang with the NFL judge?
That's not a Jet 2 holiday.
All right. So those are the two things you have to think about. There is no law of averages. Just because something improbable has happened multiple times doesn't mean it won't happen again the next time. And we don't know that anything has changed. We can't prove that anything has changed unless we were to perform this experiment, I don't know, another 1,000 times and go, hey, that's not even close to, the percentage where we said we believe that there's a 35% chance. If we did this 1,000 times and there was only, say, a 25% of the times out of 1,000, I'd be like, okay, so I think they did get better.
They're hanging from the season.
Pardon?
Some lucky monkeys.
Some lucky monkeys. All right. Oh yeah, I fixed mine. The at least one. I think you guys it says at least one, or did I fix that one?
At least one.
Yeah.
At least.
Oh, that's what threw me off around.
Yeah, totally Shepherd. You know this.
That's what got me.
And I also was typing too fast on this, and I did 30 and then not 60 and then 90. I hit the 9 instead of the 0.
69.
Why not?
No thanks.
So what we were going to do, and again, it's really hard as an experiment, is that you would, put a tack in a cup, flip the cup over, see if it lands with the point pointed down, not like straight down balancing on its point. I had someone ask me that, and I'm like, no,
Good
no.
clarification,
I'm going to sit here and massage my brain. Or it lands where it's up. Okay, that's basically the two possibilities. I suppose it is possible
There is a world.
there's a world somewhere in Inception where the
Where it never stops
it
spinning.
never stops spinning.
Good reference, good reference.
Never seen Inception.
my
So
Or have you?
here's what we were going to do is you're going to do it one at a time 30 times.
No.
Okay? And that's part of why we're not doing this. It takes a while. Okay? But then you decided, you know what? I'm going to do this quickly. I'm going to put 10 tacks at a time in the cup and then flip it over. And then redo the experiment. Do you think the relative frequency of the number of tacks landing point down would be the same as when you did it one at a time? Why not? Because there's friction.
Yes.
Mr. Mosey would be proud.
Because there's not enough room for them to be land pointing up when they've got 9 other tacks next to it.
But it's
Like
still
it'll just bump into each other.
Yeah.
Okay, so the problem is, are each tack's position independent? No, because they are interacting with one another.
Because of physics.
Oh yeah, because you're doing 10 at a time.
You're doing 10 at a time. So when you're flipping that over, they're all running into each other a bunch. Okay? Everybody good on that?
Yes.
I think so.
Okay. We're going to leave it at that.
Good stuff, guys. Really